guys, my name is Liad. Today I will discuss a data structure called queue. It's a linear data structure. What is queue? A queue is a linear data structure which follows a particular order in which the operations are performed. The order is first in, first out. So you can think queue, for example, like a line stand in front of a ticket counter. Okay, so whenever you want to buy a ticket, you have to stand in the line of a ticket. Okay, so for that, uh, if you want to enter the line, you have to enter at the end of the line, right? And the people who receive the ticket receives from the front of the line, right? And then move away. In the same way, queue data structure is built. So if you push a value in a queue, it will push at the end of the queue, and um, if you pop a value from a queue, it will be popped from the front of the queue. Okay, so whatever the value you will push first, it will be popped first, right? Because the value will be pushed in at the end of the queue. So the next value will push at the end of the queue again. So then it will be the second value. Then whatever the value you have pushed first, it will be popped first, right? So this is called first in, first out. So in a stack, when we push an element, we push it at the front or top, but in queue, we push it at the end. So when we remove an element from a queue, it removes the front element, which is the most recently added. Okay. So the functions and operations we will make in this video. Functions we will make is empty function, size function, and front function. We will make two operations, that push operation and a pop operation in this queue. Let's see the push operations. We will make the queue data structure using singly linked list. Okay, because singly linked list or linked list have a dynamic size, it's an additional advantage for us. um, so push, we know that in queue, whatever the value you will push, it will be pushed at the end of the queue, right? So this is a singly linked list. Node contains node A, B, and C. So you want to push the new node D in this queue. So you want to push it at the end. So you have to insert the node at the end of this linked list. So for that, first of all, you have to find the last node of this single linked list. Then you will give the address of the new node into the next pointer of the last node, right? Then the next pointer of the new node will be null. Then in this way you can make the push operation, right? And see the pop operation in queue, what it will be popped from the front, right? So you have to delete node from the beginning of this single linked list, right? So in this case you have to delete node A. So for that, just you have to do the uh, you have to change the direction of head. You have to do the direction to the next node, which is the second node of this single linked list, right? So you have to do the direction to the node B, then you will delete node A. Okay, in this way you can do pop operation. Let's see the code now. This is the code of queue. Firstly, we need a node class, right? Inside this node class I made all the members public. Inside every node we need a data field, and then we need a next pointer, right? So I have made the data 0 and next pointer to be null whenever the object of this node class will be declared with no value. Okay, so this is called member initializer list in C++. We can do initializing in this way. uh, in this way, firstly the constructor name, the we know that constructor named in the same name of the class name. Then after the constructor name and the parameters, then we will give a colon. Then we will initialize by this parameter list, right? You can do this in the next line, you can do this in this line, it will be the same. uh, okay, then I have initialized data with value and next pointer to be null if the object is declared with a value. Okay, so this is the node class. Then I have made a queue class. This is the data structure. Make all the members public. Then here I need two pointers. One of this is head and one of this is tail, because we need to access of the front element and the last element also, because we need to push at the end, which is tail, which will be tail, and we have to pop from the front, right? So which will be head. We need a length to know the size of the queue. Okay, then I have initialized the queue constructor. I have initialized head with null and tail with null and length with 0 by default. Then I have made three functions: isEmpty function, size function, and front function. First of all, isEmpty function will return that if the queue is empty or not. If the queue is empty, then head must be null. Then head, if the head is null, then it will return true or it will return false. Okay, the size function will return simply the length. The front function will return the front element, but if the queue is empty, then it means that the head pointer is null. Then we will say that invalid access and return -1. Okay, if the queue is not empty, then we will simply return the front element, right, which is the data of head. Okay, then see the push operation and pop operation. So to push a value, we need to reset the value. For this, we have a value in the parameter list, integer value. Then I have created a new node with initializing with value, the node data field of node. Okay, then since we are pushing a value, so we have to increment the length of the queue. Then I have checked that if the queue is empty or not. If the head is null, then the queue will be empty, and we will simply give the new node to the head and also to the tail, because it will be the first node and last node also, right? Then I will return. Then if the sibling list or queue is not empty, then I have to do some operation. For the what operation? I have to push the node at the end. Tail is the last pointer I am accessing. I have initialized it. So tail will be the last address of the last node. So we will give the new node inside the next pointer of tail, which is the last node, right? Then we will simply change the direction of tail, because then new node will be the last node, right? So then I will change the direction to be tail equals tail of next, because the next of tail is now new node, right? So this will be the tail, then this will be the last node. Okay, then see the pop operation. So inside the pop operation, I have checked firstly that if the queue is already empty or not. If the queue is already empty, then we have to do nothing, we will simply return. Then if this is not happened, then we have to delete the node from the beginning, right? So first of all, store the node inside the temp. Then the first pointer, which is head to be pointing to the next node, right? So head will be head of next. Then we will delete the node, first node. Then we have to also check that if the head is null or not. That if the queue was containing only a single value, then head of next will be null, right? The only single value, which the next pointer of which will be null. So if the queue contains one value, then after this operation head will be null. So we have to initialize the tail also null, right? Because there is no value or no node after popping this node, so tail will be also null there. Then we will decrement the length by 1. So this was all the operations. And then I have inside the main function, I have declared a queue object. Then I have done some operations. Let's see the operations by running the code. Okay, So this is the result. So firstly check that I have printed the queue size. This is 0. Firstly it will be 0, right? Because I have pushed no value. Then I have pushed 12. Okay, yes, I have pushed 12 firstly, right? So then I have pushed 10, so it will be pushed at the end, right? So I have pushed 10. Then I have pushed 30, it will be at the end, so 30. Then I have printed the font value, which will be 12, right? So it is 12. Then I have pushed again 3, it will be at the last. Then I have printed the size, so it will be 4, right? So this is 4. And I have popped two values. So pop operation will be happened from the beginning. Two values will be popped. Then I have printed the font. It will be 30, right? So this is 30. Then I have pushed for 15. It will be pushed at the end. Then I have popped two values. So two values will be popped from the beginning. Then I have checked that if the queue is empty or not. If the queue is empty, then it will print on, otherwise 0. So the queue is not empty in the case, right? Because the queue is containing one value, 15. So it will return 0. So it is 0. So then front of queue will be 15, right? Okay. Let's add some operations more. Let's pop again and see these two operations again. Okay, let's run the code now. So after popping the value, then 15 will be popped, so queue will be empty, right? Then it will return true, that means 1, right? So after 15, this is queue dot front 15. I have popped this value, then it will return 1. So this is 1. And after this I have printed the front value, because but there is no value in this queue, right? So if there is no value, then I have printed that invalid access and return -1. This is invalid access, return -1. Okay, so this was all for today. Till the next video drops, keep practicing. Thank you for watching.